xj plus kyj plus lzj. This value is substituted in the form factor value. You get the intensity value is directly proportional to square of the form factor value. Square of the form factor value. Finally you get the result of form factor for BCC structure is f square is equal to f1 plus f2 into h plus k plus l whole square. H plus k plus l whole square. This is the form factor value for complete BCC structure. This is form factor value for complete BCC structure. Depending on the BCC structure planes, you can assume 1 0 0 anything. So H K L H1 K0 L1 H plus K plus L value, you have some addition, you get the value is T. 2 is nothing but even number. 1 1 1 3. So the sum of the Miller indices value, they get either even value or odd value depending on their sum. Suppose you get the result is even, they have the maximum intensity. This H plus K plus L value, H plus K plus L value, you can add this value, you get the value is even, nothing but 2, 4, 6, 8, 10 so on, even, they get the intensity value is maximum. In a similar way, this is odd value, the intensity value is minimum. Maximum or minimum is always be depending on the form factor value, no doubt. Form factor, square of the form factor is nothing but intensity of the diffracted X-rays. The intensity of the diffracted X-rays may get maxima or minima, nothing but they get the peak values, maximum peak, otherwise minimum peak. The maximum and minimum peak values are mainly depending on the sum of the Miller indices. Sum of the Miller indices are even, they get the intensity is maximum. Sum of the Miller indices are odd, they get the value is minimum. So the maximum and minimum values is always ratio, which is in the ratio is like this. I maximum by I minimum is equal to f1 plus f2 by f1 minus f2 whole square. So at any situation, the intensity of the diffracted rays is always be proportional to square of the form factor. Square of the form factor value. So I value is always be proportional to f square. So according to the waves, I value is directly proportional to a square. First one in intermediate level. In optics point of view, particularly degree second paper optics, nothing but in light, intensity is directly proportional to r square. Square of the amplitude is here also. This is A is nothing but in terms of waves, R is nothing but in terms of light. So according to the crystal, intensity is directly proportional to f square. Intensity is directly proportional to f square. Particularly you can consider the point sized atoms. The intensity of diffracted rays I is proportional to z square. So from intermediate point of view to up to M.Sc level, the intensity have different factors. One is square of the amplitude, second one is square of the amplitude, third one is square of the form factor, so fourth one is square of the atomic number. Particularly square of the atomic number is applicable for the atoms must be considered as the point sized atoms in the crystal. You can consider as the point sized atom in the crystal. Then intensity I is proportional to z square. Here A, capital A is nothing but amplitude of the wave. Next, R is nothing but amplitude of the light, and F, capital F is nothing but form factor or structure factor or scattering factor. Here Z is nothing but atomic number. So that is the intensity of diffracted X-rays. Intensity of diffracted X-rays. So on yesterday and today class point of view, you can clearly conclude that the X-rays are diffracted on the crystal. First one, the X-rays are diffracted on the crystal. So once the diffraction is occurs, at that condition they can obey the Bragg's condition. That is 2D sin theta is called n lambda. This condition is applicable for each and every position, may or may not. We not confirmed that. It may be obeyed or not. Suppose the Bragg's condition is not obeyed for different glancing angle, otherwise different wavelength of X-rays. On that way, at that condition, X-rays are diffracted or not. How to explain? By explaining based on this form factor value. Once the form factor value is calculated, they get the graph have highest peak values. Peak values, highest peak, otherwise lowest peak. Once the peak values of intensity is observed, on that condition, X-rays are must and should be diffracted. On the diffracted condition, the intensity of X-rays always be proportional to square of the form factor. Square of the form factor. Form factor is deduced not only for single atom. It is the sum of all atoms in the crystal. Sum of all atoms in the crystal. Those are diffracted. Those are diffracted by the X-rays. So the X-rays are diffracted or not can be explained by based on form factor. Once the X-rays are diffracted, then their intensity always be proportional to square of the form factor. That form factor value calculation according to derivation point of view I showed in the last class. With respect to vector form, you can derive today class also. So on yesterday class and today class point of view, the diffracted X-ray beam is always be proportional to intensity of the diffracted X-ray beams, always be proportional to square of the form factor. So from intermediate point of view to up to today class, nothing but M.Sc point of view, the intensity value is mainly depending on square of the amplitude, square of the light amplitude, square of the form factor, square of the atomic number. This condition is applicable for the atoms in the crystal can be considered as point-sized atoms. The point-sized atoms. On that way, intensity is always be proportional to square of the amplitude. Square of the amplitude. So based on this, you can determine the every crystal structure based on this form factor or intensity of diffracted rays. Based on this one, you can clearly explain the each and every crystal structure. So this form factor value calculation is used to determine the structure of the given crystal. In this topic, number of topics are included. So each and everyone must be known and practice it. You get the final result. Okay.